This is part 2 of our review of the prerequisite skills that you will need to be successful in AP Calculus. In this video, we will review solving quadratic equations by factoring, and we will also review solving logarithmic and exponential equations like these. For number 13, you want to get 0 on one side, so we're going to have 2x squared minus 5x minus 3 is equal to 0. There's no GCF, so let's go ahead and go straight to the factoring. There's a lot of different methods for how to factor a quadratic like this, but the way I do it, just look at the first term, 2x squared. That can only be factored one way. That'll be 2x and x. Then I skip over to the third term. Ignore the negative sign. What times what makes 3? So that can either be, it can only be 1 times 3, but it does matter whether you put the 1 first and the 3 second or vice versa. So there is a tiny bit of guess and check involved in my method, but it goes very quickly and you can probably do a lot of it mentally. But I think to myself the following phrase: inner plus outer equals middle. And what I mean by that is inner we have the 1x, outer we have 6x. We're multiplying here, so we have 1x and 6x. Together this has to equal the middle term, which is the negative 5x. I can get negative 5x if I have a positive 1 and a negative 6. So that would translate into a positive 1 here and a negative 3 there. I have to check one last thing. Does positive 1 times negative 3 make negative 3? It does. So there we have factored correctly. To solve, we will use the zero product property and set each of these equal to 0. So this is going to give us 2x is equal to negative 1 and x is equal to negative 1/2. And this one gives us x is equal to 3. So these are the solutions to number 13. All right, take a look at number 14. We still want to get 0 on one side. Whatever you do, resist the temptation to divide everything by x. You never want to divide by a variable because you're probably accidentally dividing by 0 when you do that. Instead, get 0 on one side. So I'm going to subtract x from both sides. So that's going to give us x to the third power minus 4x is equal to 0. Now there is a common factor of x, so go ahead and factor that out, and that will leave x squared minus 4. This is the difference of two squares, so this will factor further as x plus 2 times x minus 2. Setting each of these factors equal to 0, well, we have x equals 0 already, but then here we will have x is equal to negative 2, and this one gives us x is equal to positive 2. So these are the three solutions to problem number 14. Number 15, notice there is a common factor of 2. When you're solving an equation, you don't have to save the 2 off to the side. You can simply go ahead and divide everything by 2. All right, because you're allowed to divide both sides of the equation by a number. So this will leave you with x squared minus 5x plus 4 is equal to 0. So let's go ahead and factor this real quick. X squared will only factor as x times x. Now 4 will either factor as 2 times 2 or 1 times 4. with an eye on the middle term of -5, we're going to go with 1 times 4. Inner plus outer equals middle, so really I'm thinking inner I have 1x, outer I have 4x. To make -5, I need both of these to be negative. Notice that -1 times -4 does give you +4. Always check that. Now if I set each of these factors equal to 0, I will get x is equal to 1, and I will get x is equal to 4. All right, problem number 16. I'm noticing that all three of these are divisible by 3. So if we divide everything by 3, we get 2x squared is equal to 3x plus 14. Let's go ahead and get 0 on one side, so we will have 2x squared minus 3x minus 14 is equal to 0. Time to factor. Look at the first term. 2x squared will only factor as 2x times x. 14 is either going to factor as 2 times 7 or 1 times 14. I'm going to go with the 2 and 7 first. Now, it does matter whether I go 2 and 7 like this, or if I put the 7 first and the 2 second. One shortcut that I use is the fact that there should not be a common factor inside of a pair of parentheses. So the 2 cannot go here because that would cause a common factor. And if the previous step had no common factor, then your next step can't have a common factor either. So the 7 must go here, and the 2 must go here. Inner plus outer equals middle. Inner, I have 7x. Outer, I have 4x. I'm multiplying these. The middle is -3, so I can get a -3 if I have a -7 and a +4. So that means a negative here and a positive here. Check one more thing. -7 times +2 does give us -14, so we have factored correctly. Go ahead and set each factor equal to 0 and solve. So if I do that, I will get x is equal to 7 over 2, and x is equal to -2. Now we will solve some exponential and logarithmic equations. So one way to solve an equation like number 17 is to rewrite these so that they have the same base. In other words, 9 can be rewritten as 3 squared. So if we do that, on the left side we still have 3 to the x power, but I'm going to write 9 as 3 squared, and then I still have the 3x minus 8. So the only way that these expressions will be equal, since the bases are equal, then the exponents must be equal. So we take this logic step that tells us that x must equal, and you know what, I'm going to go ahead and do the distributive property here. So I'm going to say x is equal to 6x minus 16. So I am going to subtract x from, let me not do that. Students get confused sometimes when the 0 shows up. I will instead subtract 6x from both sides. So that's going to give me -5x is equal to -16. If I divide both sides by -5, I will get x is equal to 16 over 5. So that is the solution to number 17. For number 18, we will have to use a different method. There's no way to rewrite the number 8 with a base e. Instead, what you want to do is take the natural log of both sides of the equation. So this will become natural log of e to the 4x minus 5 power is equal to natural log of 8. Well, if you take the natural log and with a base e, these are going to cancel each other out. So you're going to end up with simply 4x minus 5. Natural log is base e. It's understood to be base e. So you have a log base e and a base e. They cancel each other out. So we have 4x minus 5 is equal to the natural log of 8. We just have to get x by itself. So if we add 5 to both sides, we have 4x is equal to natural log of 8 plus 5. And then x is equal to the natural log of 8 plus 5, all divided by 4. So that's the exact answer for problem number 18. For problem number 19, notice that both sides are divisible by 4. So if we divide both sides by 4, we are going to get a natural log of x plus 3 is equal to 6. I can get rid of this natural log by doing a base e under it. So I'm going to go ahead and put a base e on both sides of the equation. So base e, base e. Base e and natural log are inverses, so they cancel each other out. So you will end up with simply x plus 3 is equal to e to the 6th power. And subtracting 3 from both sides, we get x is equal to e to the 6th power minus 3. For problem number 20, we will need our logarithm properties. So let's review 3 properties of logs. We learned a product property. If I have the log base b of p times q, this can be rewritten as a sum. So this could be rewritten as the log base b of p plus the log base b of q. And this is a two-way street. If I had the log of something plus the log of something, I could rewrite that as a single log of a product. We also had a quotient rule. If I had the log base b of p divided by q, then this will be the same thing as log base b of p minus the log base b of q. So a quotient can be rewritten as the difference of two logs. Or if I see a difference of logs, I could rewrite it as a quotient. There was one other rule. It was a power rule. So if I had the log base b of, let's say, p to the q power, this can be rewritten as q times the log base b of p. So when we have the log of something with an exponent, we learned that that exponent can be put out in the front. So these are 3 properties of logarithms that you should just walk around carrying in your head at all times. You never know when you're going to need one of these. For this particular problem, we only need the first one. Notice that we have the log of something plus the log of something. So we can rewrite this as a single log of a product. So I'm going to use that property and rewrite this as the log base 2 of x minus 3 times x minus 1. And that equals 3. If I want to get rid of this log expression, I can give each side of the equation a base 2. So I'm going to put a big old base 2 right here and right here. So base 2 and log base 2 cancel each other out. So on the left side of the equation, I will just have x minus 3 times x minus 1. On the right side, I have 2 to the third power, which is 8. Let's go ahead and multiply this out. So I'm going to get x squared. So I'm just doing the double distributive property. So I'm doing x times x and x times negative 1. So that's going to be negative x. And I'm doing negative 3x and positive 3 is equal to 8. So I've got x squared minus 4x plus 3 is equal to 8. If I subtract 8 from both sides, I'm going to get x squared minus 4x minus 5 is equal to 0. Hopefully this will be factorable. So x squared will only factor as x times x. 5 will only factor as 1 times 5. I need to get a middle of negative 4, so I'm going to do a positive 1 and a negative 5. Positive 1 times negative 5 is negative 5, so this is working out great. Using the zero product property and setting each factor equal to 0, I'm going to get x is equal to negative 1 and x is equal to positive 5. You have to be careful with logarithms because looking back at the original problem, you can't take the log of a negative number. It just doesn't make sense. That doesn't mean that your solution can never be negative, but you have to imagine plugging the solution back into the original problem and make sure that you're not getting a negative number inside the log. So if I take the solution of negative 1, if I were to substitute negative 1 in both of these, well, negative 1 minus 3, that's negative 4. So that's a problem. And over here also, negative 1 minus 1, that's negative 2. So we have a negative number inside of a log that is outside of the domain of a log function. So this solution is extraneous. It's not really a solution. If we take the number 5 and plug that in instead, you'll see that the number 5 works out okay. Because we have 5 minus 3, that's 2, 5 minus 1, that's 4. We do not get a negative number inside the log. So we actually only have one solution, and that's x equals 5.